Now let's have a look how this sell token function, the actual logic for the sell token function should look like. Obviously, it's very, very similar to the buy token function, and it's just in the other way around. So in this case, our cheapest offer is the first one that gets processed or executed once it gets matched. And we are not talking about executing orders yet. We are just taking new orders into the order book. And let's have a look now into the sell token function. Now, obviously, the interface of the sell token function, the arguments that it can get as input parameters are exactly the same. So you give it a symbol name. For example, I want to sell the fixed token. You give it a price in Wei. I want to sell it for 600 Wei, and I want to sell 1,000 of them. First of all, we have to even get our fixed token index from the symbol name. And we do this with the get symbol index of row function that we wrote earlier. And then we have a look how many ether are necessary on the buy side in order to sell all of our tokens. Here we do some overflow checking. Obviously, the total amount of ether that's necessary must be larger than the amount or equal in case we are selling like for a price of 0. Then the total amount must be larger than the price. We are multiplying here, so it cannot be lower than that. The token balance, because we are trying to sell our tokens, so we must have more tokens in our balance than the amount we are trying to sell it. And if we are deducting the amount, it must still larger or equal to 0. And here's our actual overflow check. This is just a balance check, but the overflow check is also necessary in order to see that we are not overflowing. Now let's check the balance plus the amount for the ether that we are trying to get in order to sell our tokens. So the balance for our address in ether must be smaller or equal than the balance of our address plus the ether that we are getting through the sale of our token. So if all of this goes through, if all of this runs through, and this is basically the very basic checks, then we can deduct the amount of token that we are trying to sell from our balance. So usually people just do this here to try to see if the token balance is, if there are enough tokens in the balance that we can sell, and then we deduct it. I usually do also some overflow checking just to be sure that there's nothing going wrong. Now then we have again our if-else branch, our if, and this is the first one. This actually creates the limit orders if there are no buy orders yet. So if there is nobody we can sell our tokens to, or if the current buy price is smaller than the price that we want for our tokens, then we have a limit order. Because if the current buy price is larger or equal than the price we want for our tokens, we can actually execute the order immediately, but we don't do that because we are writing this in another lecture in this course. But if you have a limit order, I have put the logic for the actual limit order in another function, which is here. And when this function is finished executing, I'm going to emit the event limit sell order created. Let's have a look at this function now. This function is also very, very similar to the add buy offer. It has the same arguments. It will increase the sell books for this price, the offer's length, and it will add a new offer to this offer's mapping. Let's have a look on the top first, how this offers mapping looked like, just to be all on the same page. We have our token struct, which is here. We have a mapping for a buy book and a mapping for a sell book. And this is a struct, an order booked struct. And in our order book, we have another mapping for offers, and we have an offers key and the offers length. So we have several offers, and we store in the offers key where we are at, and in the offers length, the amount of offers that we have. Because if you remember back, and I mentioned this again, because it's not very usual for other programming languages, all possible keys are initialized by default. So even if you call the offers mapping of 1 million and you get back an offer, but the amount will be 0 and the address will be 0. So we have to store somewhere the offers key where we are at and the total length of the offers mapping here. And we increase this. Let's go back down. Where's the cell function? Here we are. We increase this, and for the new offers length, for the new key in our mapping, we assign a new offer. Now, obviously, if it's the first offer for this price, then we again have to look in our cell book where we place our new pricing within this linked list. Because if you had some pause between the last lecture and this lecture, I'm gonna repeat myself maybe. Our offers, our cell book is a linked list, and we have to adjust the higher price and the lower price in order to see from the entry in our order book before this price, how can we get to our current new offer, and in the higher price, how can we go back to our new offer. So we have to adjust the next entry's lower price and the previous entry's higher price. And in this case, if we have the first entry in our book, it's very, very easy. We just add our first entry and we set the higher price and the lower price to 0 from our current entry. So we have no linked list. We have a linked list with one single entry. Now, if we have the highest price, so we have the last element of our cell book and we have a new higher price than the last price, it's also very easy. We just adjust the highest price, higher price, and say, now we have, you were the highest price, but our price is higher than that. So we say the highest price, higher price is our new price, and our new price's lower price is the previously highest price. And there is no higher price than this one. In both cases, the highest sell price will be the price in way that we want from someone who is going to buy something. The other way around, if our current sell price, so the lowest current price, is larger than the price we want from someone in order to, buy the tokens, we have our first element in our sell book. So in case of our first element, it's also very easy. We set the current sell price's lower price to the price that we want, because we have one new element at the beginning of our linked list, and our own entry's higher price is the current sell price. The lower price again is 0 because there is no lower price at the moment. And additionally, our current sell price, so the lowest price in our sell book, is our current price in way that we want from someone who want to buy the tokens from us. Now this is the fairly easy part again. And on the other hand, if we are somewhere in the middle, we have to find the right spot. We are going here from the lowest price, which is the current sell price, to the highest price. With every iteration in our while, we are setting the new sell price to the higher price of the current sell price where we are at. So if we have 4 entries, let's say somebody want to sell tokens for 100, somebody want to sell for 200, somebody want to sell for 300 and for 400, we start with 100, which is the current sell price. Are we in the right spot? Yes or no? Let's say we are not in the right spot. Next one will be 200. 200, are we in the right spot? No, we are not in the right spot. Next higher price will be 300. Are we in the right spot? No, and so on. Probably if nothing of the logic here holds, then we find the right spot here. So in our case, we have a look if the sell price is smaller than the price in way, and the next price is larger than the one that we are trying to sell our tokens for. Then we have found the right spot. So in the center of the current price, which is smaller, and the next one, which is larger, we want to place our entry in the sell order book. And then we just have to adjust the lower price and the higher price of the previous and the next element. So in our case, we add a new entry. We set the lower price to the price that we found is smaller than the one that we are trying to sell, and the higher price of the next element. Now we take the higher price's lower price and set it to our price, and the lower price's higher price, we set it also to our element. So we have added a new element into the linked list. Additionally, we set found it to true. So as long as we haven't found it, we run the while. This is all we have to do in order to actually add a new offer to our order book. And in the next lecture, we are going to implement the functions to actually return our order books, and then we can test it.